fifth driven gear, fifth drive gear, and fifth and reverse synchronizer and shift fork removal part 1. There's a shift rod snap ring and a snap ring that holds the synchronizer on that will need to be removed. The first thing is to de-stake the output shaft nut. I'm going to use a diamond point punch to de-stake the nut. This punch is not required, but it's helpful. The mat code diamond point chisel part number is LD66A. The chisel goes into the cutout on the output shaft where the nut was staked. Use a hammer to tap on the chisel to de-stake the nut from the output shaft. If you try to loosen the nut without locking the shaft will spin and it will be difficult to remove the nut. The output shaft needs to be locked so it won't turn. In order to do this, you will engage the transaxle into 2 different gear ratios at the same time. This will be accomplished by moving one of the shift forks with a screwdriver through the shifter cavity. The screwdriver can be leveraged against the housing through the guide pin hole. The center shift rod is now moved to the right to put the transaxle into gear. That was a single gear selection. And now I'm going to remove the bolt that holds the 5th gear shift fork to the shaft and move the shift fork and synchronizer down into 5th gear. Take a note that the shift fork bolt is a specialty bolt with a large shoulder. Pushing the synchronizer down engages 5th gear. Now the transaxle is into 2 gears at the same time and the output shaft will not rotate. Now the nut can be removed. The same process will be used to torque the new nut during assembly. This is a one-time use nut and should never be reused except on practice transaxles in a school learning environment. The synchronizer sleeve and shift fork can now be removed, but first take a close look at the sleeve because it is directional. This means that there is only one proper way, but you might be able to assemble it backwards. Notice the edges of the splines are flat and not pointed. Now when I remove the sleeve and turn it over, we can see the splines are pointed. So the pointed side goes down. You need to make a note of this. Take a picture or write it down. Also note that the splines that align with the synchronizer keys have a spline on either side missing. This is to make sure it is assembled correctly. Take a close look at the synchronizer keys. Some are symmetrical, which means they are the same on both sides. These keys are not. There is a notch on one side to denote the installation direction. Also notice the bump is not in the middle of the key. These keys are directional. The snap ring on the input shaft is known as a 5/8 snap ring because the snap ring is about 5/8 of a full circle. Because of this, typical snap ring pliers cannot be used to remove the snap ring. The typical method in the field is to use 2 large flat blade screwdrivers and a hammer to remove the snap ring. The edges of the screwdrivers are used against the edges of the snap ring and a hammer is used to hit on both screwdrivers at the same time. I'm going to use a custom-built specialty tool to remove the snap rings. The tips are hardened and have a notch designed to catch the tip of the snap ring. Loosen the lock screw, adjust the spread of the jaws to fit the edge of the snap ring, and tighten the lock screw. For safety reasons, and so that you don't lose the snap ring, cover the shaft with a rag. Then with a hammer, strike the end of the tool. Let's take a closer look. You now have a better view of why these are called a 5/8 snap ring, because they are approximately 5/8 of a full circle.